All right, just so everybody knows, we are streaming on Facebook. I'm also going to start recording the webinar. So just so everybody knows, we're going to go ahead and get started here. Everybody knows, we are streaming. Sorry about that, a little feedback from streaming on Facebook. Anyways, thanks everyone for being here tonight. My name is Margaret Stern, and I'm the Program and Communications Director for the Susitna River Coalition. We are a small grassroots organization based up in Talkeetna, Alaska, and we monitor the whole of the Susitna watershed and engage with a lot of fisheries work and policy and different development projects in the region, and are a voice for the inhabitants of the Susitna watershed. So again, thanks everyone for being here. This is our January winter speaker event. We hold one event each month during the winter time, and we are excited today to have Parker Bradley from the Alaska Department of Fish and Game here with us to share his work with invasive pike in the region. So Parker Bradley is an invasive species biologist with the Alaska Department of Fish and Game. He's based in Palmer, where he mostly focuses again on invasive northern pike. He's been in this position since 2018. And prior to that, he was a habitat biologist in Fairbanks with the Alaska Department of Fish and Game. He earned his master's degree in fisheries at the University of Alaska Fairbanks and received his bachelor's from the University of Kentucky and the University of Montana. So we're really excited to have Parker here tonight. I know everybody's probably been out there ice fishing quite a bit, catching pike, so we're excited to learn more about them. So I'll pass it on over to you, Parker, and thank you so much.
Cool, thank you. Let me see if I can do a share screen right quick. Cool, seeing that okay?
Yes.
All righty. Hello, everybody. She said my name is Parker Bradley with the Alaska Department of Fish and Game, and I'm going to be talking about pike this evening. So real quick background on pike in Alaska. They're actually native to a majority of the state, almost everything north and west of the Alaska range. So that's kind of that diagonal red line area shown there. And the southern boundary of their native range is the Alaska range. Now, the reason they're not native here in the South Central region is because this region was covered up in glaciers up until the last glaciation period, which ended about 11 or so thousand years ago. After the glaciers receded, the pike were not able to essentially swim up and over the Alaska range. So that's why they're not native to this region. Now, real quick, just want to define an invasive species because I kind of see this term misused just a little bit. But it's a species that is introduced into a new area by people where it's not native and it's causing some kind of harm, whether that be environmental, economic harm, or harm to human health. So they have to meet both of those criteria. Here's some pictures of other invasive species. Fortunately, not in Alaska, but definitely throughout the lower 48. So the history of pike in South Central began in the 1950s when they were first introduced to Bolchitna Lake. There was a landowner there with a float plane that flew up to the native range by Fairbanks. It's believed in Minto Flats, caught some pike, moved them down here, released them. And not long after that, someone moved them to Alexander Lake, just to the south, as you can see there. And then in the 1970s, they were first discovered on the Kenai Peninsula. It's believed these came from western Alaska. And then a flood also occurred, allowing the pike to escape Bolchitna Lake into the Etna drainage. And then a lot of the spread really occurred in the 80s and 90s. And this is kind of what we're looking at today. This thing. Now, one big question we get, and rightfully so, it's a good question, is why are pike considered a problem down here, but not a problem in their native range? Well, indeed, kind of no matter where pike occur, they're a top-level predator playing an important role in the fish assemblage and the ecosystem. In their native range, they are a very popular sport fish. They're also a very popular subsistence species. And they even co-occur with some of the largest salmon runs in the world in Bristol Bay. But what it kind of really comes down to down here in this region is the role that pike habitat plays. And that's kind of why they're a problem to this extent that I'm going to explain later. So when I talk about good pike habitat, really what I mean is places that are very weedy, shallow water, slow moving water. That's where pike are really effective at feeding. That's where they spawn. That's where the juveniles have very high survival rates. So recruitment is a lot higher in these ecosystems. So where you have good pike habitat, pike are just going to do a lot better. How this sort of can play out in their native range, I'll kind of show you an example here, actually in Minto Flats, just to the west of Fairbanks. Now, this is an aerial image from the anadromous waters catalog. So all the blue lines you see here are documented anadromous habitat. As you can see, there's not really a whole lot. We have the Tanana River down here on the bottom left, the Chattanooga River that flows up to the Steese Highway by Fairbanks there. In the top, and then this whole wetland complex is kind of considered minto, and it's pretty much dominated by northern pike. And in the summer, pike are very prevalent through here, but come wintertime, they actually move to very specific overwintering locations. And in this case, one of the big ones is in the Chattanooga River, as you can see, overlapping with the anadromous, habitat zone. So they overwinter there, but at that time, there's not salmon occupying that part of the Chattanooga. They're further upstream, either in the gravel, getting ready to hatch in the spring, or in some ponds and lakes up there, overwintering. In the springtime, pike leave that area, go back into Minto Flats to spawn, and at that same time, the smolt outmigration is occurring. So pike and salmon overlap in the same space, but not in the same time in this particular ecosystem. So that's how they're able to kind of coexist in a drainage in the interior. Another good example is in Western Alaska, where you have these huge complex drainages, really deep lakes. They occupy the lake at the same time, but they're in different parts of the lake. Your rearing sockeye salmon are going to be out in the middle, and your northern pike are going to be kind of limited to the edges where there's shallower, weedier habitat. But here in South Central, where pike have been introduced, juvenile salmonids often reared in the same habitats. And there's a high degree of overlap. And where there's that overlap, we see the highest amount of impacts. But where we have some habitat variability, can mitigate some of the degree of the predation risk. And I'll kind of go over that in a bit. But what happens is when pike get introduced into a new system, especially if the habitat is right for pike, we can see very heavy predation on juvenile salmon and trout. In some places, they actually extirpate them. And I'll go over some of those areas shortly. But if you think about it, juvenile salmon and trout, silvery little fish, they haven't evolved to this level of apex predator in their ecosystem. And they're just very vulnerable to predation. They really stand out, and they're often the first to go. If the conditions are right to where predation levels are high enough, they extirpate the salmonids, then often pike will shift their diets to other things like sticklebacks, sculpins. If the conditions are right where those are gone, then really all that's left for them to eat is invertebrates. And once a pike population is dependent on eating invertebrates, their growth rates really, really go downhill, and you end up with a stunted pike population. You would think that they would maybe eat themselves and, be happy doing that. And certainly that does happen, but I'm going to show you kind of how infrequent those cannibalism events occur. They mostly really eat on insects at this point. So real quick background on the anadromous waters catalog. What it is essentially a catalog of waters that are important for the spawning, rearing, or migration of anadromous fish. And here is a snapshot of the Matsu Valley showing all the anadromous waters, all the streams, all the lakes, all the ponds, and highlighted blue there. Now, when I say anadromous, what I really mean, a lot of people think, oh, you're talking about salmon. And yes, I am, but there's a huge list of species that could be considered anadromous in the state of Alaska. Whitefishes, lampreys, smelts. So a lot more than salmon can be in the catalog. Now, in the valley here, it's very salmon heavy, but just, for your information. So what I'm going to do is actually go over a series of water bodies in different categories. And The different categories are going to represent kind of the relative degree of impacts that pike have had in that system. So for example, category 1 water bodies are water bodies with pike present, but not necessarily causing noticeable impacts to anadromous fish at this time. You could say they're doing all right. A good example of that, you could say, is Big Lake. As a result of the type of habitat it has. It's a very big lake with deep water, lots of refuge for the fish to escape predation. We did some netting there a couple years ago and got our hands on a handful of pike. With all the pike we catch, we look at their stomach contents, document it, and I kind of see pike stomachs as almost a surrogate for minnow trapping. They're like a swimming minnow trap. They're going to tell you what other fish are in the ecosystem. So in this case, for Big Lake, we saw a pretty good even number of juvenile salmon, mostly coho, some sockeye, rainbow trout, sculpin, stickleback, lamprey, and then invertebrates as well. So that tells me, there's a good amount of those other species present in Big Lake. Another good example of what I would consider category 1 water bodies would be the east side Parks Highway streams. So Willow Creek, Sheep Creek, Montana Creek, those in that region. These are generally higher gradient and not really conducive to the pike taking over due to the lack of prevalent pike habitat. There might be a little bit in the lower stretches of the creek for sure, but a majority of them are this higher gradient type habitat where pike might be present, but they're just not going to take over. Category 2 water bodies. Now we're getting into some territory where we're starting to see some impacts from moderate to severe on anadromous fish. A good example of that is Nancy Lake. If I can move this thing. So these graphs are essentially pie charts of stomach contents from pike for the past 4 years, starting in 2020. And it's the trends I'm going to highlight here that are kind of concerning and why I would put Nancy Lake in a moderately impacted category. So when we first sampled it, really our efforts started ramping up in 2020. Juvenile salmon made up nearly half of the stomach contents for pike. The year after that, that decreased down to 14%. The year after that, down to 7%. And then last year, that was 4%. Another interesting trend we saw was with lampreys. Initially, about a quarter of their diets were made up of lampreys. That went down to 2% the next year, and then that's 0%, and then 0% last year. So they seem to have really taken a hit. Stickleback, kind of that secondarily preferred species that pike begin to consume once, some of the salmonids are gone. It was initially 5%. That jumped up to 52%, up to 60%. And then back down to 33% this last year, but that was due to the increase of invertebrates now becoming prevalent in their diets. Because in 2020, it was 2%, then that went up to 18, 27, and now we're up to 58%. So really significant shifts in their diets in just 4 short years in Nancy Lake, and pretty concerning at that. When we were first doing this sampling in 2020, growth rates of pike were really, really good. They were kind of off the charts. But here lately, the growth rates have really, really decreased, and that's a result of much more poor quality food source for them. Another example of what I would consider this case severely impacted, it's not in the Matsu, but still a good example, is the 3 Mile system on the west side of Cook Inlet near Beluga, where we've been doing a lot of work since 2018. At this point, the diets of pike are over 90% invertebrates, with juvenile salmon kind of holding on by a thread and some other species making up a smaller percentage of their diet. Now, lastly, we have category 3 water bodies, which unfortunately I call ecological dumpster fires because that's really what they are. These water bodies no longer serve as functioning anadromous habitat due to the pike predation in that system. So this is pretty much bad news when you get to this point. A good example of that would be Stefan Lake. And as you can see, we're just south of Big Lake there. It's in the Goose Creek drainage. Last year, I think we caught just around 600 pike or so from Stefan Lake, looked at all their diets, or stomach contents, and invertebrates virtually made up 100% of their stomach contents. As you can see, like other pike, I think we maybe found 10 or 11 other pike in their stomachs. I mean, really low cannibalism rates, you know, a handful of rodent and birds, but these fish are now subsisting on invertebrates, mainly scuds, dragonfly larvae, leeches, that type of thing. And their growth rates have really gone downhill. But that's just one example. There's actually a lot more of those. So we have the Stephon Lake and Goose Creek drainage I just highlighted. North of that, actually in the Little Sioux drainage, we have over here West Horseshoe, Feather Lake, and Hourglass Lake all kind of connected. Historically rearing coho salmon habitat. That's pretty much taken over by pike at this point. In the Meadow Creek drainage, we have a couple of lakes, Beaver House and Jerry Lake, along with Twin and Long Lake over there. We believe these systems have been invaded relatively recently by pike, probably 2019, 2020. So pretty recent on that, and they've already taken over. So pretty sad story there. Moving up a little bit to the Nancy Lake Rec area, virtually all of that's now pike habitat. Lynx Lake, Redshirt Lake, all the South Raleigh, Tanana, you know, there's no anadromous fish left. All the way down Fish Creek to Flathorn Lake, pretty much dominated by pike. This has probably not seen salmon for maybe decades. It's been a long time. North of that, we have Long Lake and Shirley Lake that flow into Willow Creek. Again, pretty much taken over by northern pike at this point, historically spawning and rearing coho salmon habitat. Moving to the west side of the Susitna now, where we start to see a lot more prevalent deal pike habitat, that low gradient weedy systems. Trapper Lake, I'm sure y'all are familiar with that one. It's a pike fishery now, pretty much taken over. All the trips that flowed into Trapper used to be rearing habitat. No longer the case. Moving to the west side of the Yetna here, we have the Alexander Creek drainage, which I'll touch on more in a bit. But Alexander Lake right here, along with all the tribs that flow into it, essentially no longer functioning anadromous habitat. Once pike took over the lake, it essentially shut off these upper tribs from anadromous fish. And then same with Sucker Lake down here as well, and the tribs that flow in. Now, Alexander's in pretty rough shape in general. Really, the whole upper half of the drainage is almost void of salmon itself. Really, the salmon stronghold in this system is Sucker Creek and then the lower part of Alexander. Now, kind of give you an idea of how this can really shake out in a drainage and how not all anadromous habitat is created equal. Some is really much more valuable than others. Type of anadromous habitat. So I'm going to focus on the Fish Creek drainage here, which is flowing out of Big Lake. We have pike in Big Lake, category 1, and also pike in 3 Mile Lake, which is a trib to Fish Creek. At this point, category 2, we think pike have gotten in there relatively recently within the past few years. Given the habitat, it might turn into a 3, time will tell, but it's very heavy pike presence in this system. So what they've done, probably about 8 years or so ago now, there were some studies done on the movement of juvenile cohos through the Meadow Creek and Fish Creek system. They use these little tags called pit tags, track their movements all through the whole drainage. And what they found is for the coho salmon that were hatched in Fish Creek here, about 31% of them overwintered in 3 Mile Lake, 68% went to Big Lake to overwinter, and then the remaining 1%, I think, went up Meadow Creek. But what's interesting is 3 Mile Lake is about 2 or 3% the size of Big Lake, yet supports just over 30% of the overwintering coho salmon from Fish Creek. Now, when you have a situation where pike are in there contributing to very heavy predation, that's going to have a very significant impact on a very large proportion of those coho salmon from Fish Creek, a disproportionate amount of impact. And so what that means is the way these systems can kind of function and impact kind of the greater salmon population outside of just where that small pike population might be, because juvenile salmon are moving all over the place all the time, particularly cohos, kings, sockeye as well. And when they find themselves in these systems, it's kind of bad news. So these 2s and category 3 water bodies can serve as not only ecological barriers, preventing pike from juvenile salmon from accessing the habitat they need, but actually they function as what we call ecological black hole sinks, where if fish make it into that location, they're removed from the population, and they continue to be removed from that population if they move into that type of habitat. So it can be very destructive to a drainage in the salmon population there. So now I'm going to kind of get into some real numbers for you all to grasp on. In the Mat-Su Valley, there is a total of 216 anadromous lakes and ponds, which total up to almost 32,000 surface acres. Now, for this analysis, I excluded all the streams and rivers, so mapped out is simply just all the lakes and ponds that are documented for anadromy. So as you can see, quite a bit of it out there. We can break that down by species, and as you can see, coho salmon are documented in occurring 185 of 216 of those anadromous water bodies. You can see the equivalent surface acres there that they occupy, followed by sockeye salmon, chinook salmon, pink chums, and others, with others being mostly whitefish and some lamprey. But moving forward, I'm just going to be talking about lakes and ponds here. So what I did is I added up all of the different water bodies in each category throughout the Mat-Su Valley. So for example, category 1, I estimate that there's 8 water bodies falling in that category, which totals about 7,300 surface acres. And again, these are water bodies with pike, but kind of minimal impacts at this point. That actually equates on a surface acreage basis to about 23% of all AWC or anadromous waters catalog lakes and ponds. So pretty big number, almost a quarter. Moving on to category 2, so lakes where we're starting to see moderate to severe impacts. I summed up 15 water bodies, which totals nearly 4,300 surface acres, and that is 13% of all anadromous lakes and ponds. And then finally, category 3, lakes that, essentially completely destroyed, 41 water bodies totaling 8,100 surface acres. And that equates to just over a quarter of all anadromous lakes and ponds in the valley. So that's a rather significant number that's essentially just deleted from functioning anadromous habitat. There's also water bodies I'm not too sure about. They likely have pike based on their location and proximity, connection to other pike waters, but they're often really small water bodies, sometimes only a couple of acres and maybe difficult to get to. So we just don't have the time or ability to get to all these locations to sample, but about 59 water bodies I put in that category, totaling over 3,500 surface acres, which is another 11% of kind of water bodies up in the air. Now, to kind of summarize everything for you, in summary, again, category 1 waters make up 23% of all anadromous lakes and ponds in the valley, followed by 13% for category 2, 26% for category 3. And so when you add up just the category 2s and 3s, so water bodies that are moderately to severely to catastrophically impacted, that's 39% of all anadromous lakes and ponds in the valley, which is rather significant. If you include category 1s where pike are present, that's 62%. Now, don't forget about the ones that probably maybe have pike. The degree of impacts currently unknown, another 11%. So if you assume those have pike, then that would total almost 3/4 of the water bodies that supported salmon that are lakes and ponds, at least have pike. Some of them are impacted very significantly. And then that leaves about 27% pike free at this time. Now, this is also a minimum and doesn't include streams and rivers, as I highlighted. And this number is also growing every single year. We're constantly finding pike in new locations. They're still on the spread, and it can still get much worse. There's several drainages we're quite worried about. And then another thing to keep in mind is waters only transition in one direction from a 1 to a 2 to a 3 without human intervention. So for example, a water body that's currently a 2, it's never going to resort back to a 1 on its own. Or Stefan Lake, that's a 3, will always be a 3. It'll never turn back to a 2 on its own without human intervention. And in some cases, we've been able to cause that reverse. And then also, this does not include impacts to non-anadromous waters where resident species were present. burbot, suckers, sticklebacks, sculpin, rainbow trout, that type of thing. So I'm going to shift gears a little bit and kind of talk about some things that we're doing, starting with suppression projects. And I can't talk about suppression projects without highlighting Alexander Creek. This is our biggest suppression project that we have going on. And it's a good example of how pike should be considered a significant threat under the right conditions and how they can completely destroy a fishery. Historically, Alexander Creek supported multiple fishing lodges, charter companies, air charters, boat rental facilities. It was a multi-million-dollar industry, and that fishery closed in 2008 due to low returns, and it's been closed ever since. As a result, that industry has collapsed. So Alexander Creek, in case you're not familiar, here it's located on the map. Relatively remote. You can snow machine, boat there, fly there. There's no roads going there, at least not yet, but it's relatively remote, so difficult to get to for most folks. It's the first in a series of major trips to the Susitna. As you can see, it's pretty low wind on the drainage. At the headwaters is Alexander Lake, about 800 surface acres. And then the creek itself is about 40 river miles long. And again, pike were introduced in the 60s into the lake, and it took them a while to actually make their way all the way down the creek drainage. And it wasn't until the 1990s that they were first discovered in the lower end and established themselves throughout. So really, this suppression project that we do, the main goal is just to simply drive down pike abundance. We know we're not going to get them all. We just get as many as we can to allow for some increased survival of juvenile salmon. So what we do is we set gill nets throughout the creek. There's about 60 locations we net, give or take a bit each year, to remove the pike. And typically we target these oxbows and side sloughs where we have that slow water. That's where pike are spawning and very concentrated in the springtime. And this project began in 2011, and to date, we've removed just over 30,000 pike from the system. We look at all the stomach contents from the pike, so we're able to detect trends in juvenile salmon. And in addition to that, we also do aerial escapement counts for Chinook salmon, which this graph shows. So what we have is year on the bottom and number of Chinook counted on the y-axis. And this dates back to 1979. So we have counts from Alexander Creek in the red bars, and then the Talachwitna River in the black bars. And the reason I included the Talachwitna is because these have very similar escapement goals, and they're very close to each other. The Tal is just on the other side of Sleeping Lady. So real close. And as you can see, through the 80s and 90s, they pretty much tracked together very, very well with peaks and troughs with salmon returns. But in the early 2000s is when we really began to see the impacts from pike and Alexander. This time period, especially like in 2004, saw huge Chinook returns all through the valley. I think the Deshka passed around 58,000 kings through the weir. It was just a huge return. And that year, Alexander barely even met minimum escapement. And as you can see, when they began to deviate in the early 2000s, that deviation is now pretty much consistent each year. And right now, Alexander returns are averaging about 25% of what the Tal was or is. So if you assume really the only difference between these two systems is the heavy presence of pike and Alexander, if you assume they would have continued tracking together without the presence of pike, that's about a 75–80% reduction in the production of Chinook salmon in Alexander from pike predation, which is really significant. Now, you might be wondering, you know, how do you just get rid of them all, or can we get rid of them all? How does that work? Well, in some locations, eradication is the goal. And when we do that, rotenone is our #1 tool. It's a fish pesticide that we use. But before we go down that road, we really have to ask ourselves several questions. The first being, is it possible to do? Meaning that can we actually get all the pike out, or is the system too big and complex? Second, is it feasible? Can we actually afford it, get the funding to do it? Or is it simply too big or too remote? The third thing we got to ask ourselves is natural reinvasion preventable? So for example, if we treated a system that flowed into the Susitna they would likely just come right back in the next year or so when we'd be right back to where we started. So generally, we try to target areas where we can get them all out of a complete drainage or lake, and they wouldn't naturally come back. And then also, why are we doing it? Is it for system restoration, or maybe to prevent spread from that location to a more vulnerable location? And we've done projects for both of those reasons. So real quick, I'll just kind of highlight some projects for context, show you where a lot of this effort's really focused. Anchorage has received quite a bit of efforts starting back in 2008. Here's a list of all the projects we did, with the last ones being in 2022. And the Kenai is actually where we spent most of our effort, dating back to 2008. There's been about 20 or so water bodies that we've treated on the Kenai Peninsula, with the last one actually being in 2021 in Vogel Lake, which is on the very northern tip of the Kenai Peninsula. And with the completion of that project, knock on wood, we aren't aware of any more pike populations on the peninsula at this time. And that's why we focus so much effort there, is because we knew or thought there was at least a chance of getting rid of, most of the pike. There's only been really one major project in the Mat-Su Valley for pike eradication, just due to its, expansive interconnectedness and prevalence of pike through the region. But that was at Kings and Anderson Lakes, which that occurred in 2020. And the reason we kind of started with this project is because it is at the headwaters of Cottonwood Creek drainage, which flows through Wasilla there. And we wanted to prevent them from spreading from that location. We took some measures to kind of keep them contained to these locations until we could eradicate them. And hopefully we were able to do so. But really, this is the locations that we focused on eradication. We haven't done any, in the greater Sioux drainage, just because of how expansive and interconnected it is. So now I'm going to kind of touch on some research that we're doing. There's some really interesting stuff coming online. One of the big ones is the ability of pike to move through Cook Inlet, which is a brackish water system. And most likely, the Susitna serves as a large source of pike, probably moving into the Susitna or Cook Inlet every single year. There's 4 locations where we believe pike got established by swimming through Cook Inlet, 2 in Anchorage that I'll highlight, that one on the Kenai Peninsula, the Vogel Lake, and then one on the west side of Cook Inlet near Beluga. Now, this research I'm talking about, it's called otolith microchemistry. So I'll kind of try to explain it the best I can, but fish have otoliths. It's the inner ear bone, and it's very common for fish biologists to collect them to get a variety of data. In this case, we collect the otoliths for looking at the chemical signatures throughout the life of that pike. So the bottom there you can see is a picture of the otolith, and we send these up to UAF. They have a big machine that can read the chemical composition of the otolith from the time that fish was born, which is the center, all the way to the edge, which is when that fish was caught. And so this graph basically shows that, and that red line represents a chemical signature that is specific to Cook Inlet. And as you can see, there's 2 kind of subtle but definite peaks that approach that. And to me, that suggests that this pike swam from somewhere through Cook Inlet and then up into the Campbell Lake system. The other lake that I highlighted on the map there was Westchester Lake, and we saw a very similar thing with the chemical signature consistent of being in Cook Inlet. And what's interesting is it looks like this movement occurred in Campbell Lake when the pike was about 1 year old, and then for Westchester about 2 years old. So these movements seem to be occurring when they're pretty young, and we have this type of data for the other systems I highlighted, like on the Kenai and West Cook Inlet as well, but a really unique piece of research that we're starting to utilize. But this left us with some more questions, mainly being how tolerant are pike of brackish water? We know pike, there's a population that lives in the Baltic Sea, which is brackish, but we didn't know how that translated to Alaska. So we did our own salinity trial. And what we did is we collected a bunch of pike, put them in these totes, and exposed them to some known salinities. And that's what this graph here shows. So we tested salinities ranging from 0 being our control to 7 to 14, 21 to 28 parts per thousand. For reference, 35 parts per thousand is considered fully marine. So we tested some pretty salty water there. And then this vertical bar represents the amount of time that they lived. So we just simply watched and see how long they lived. So at 0 and at 7 parts per thousand, they lived for the full duration of the study, about 96 hours or for 4 days. At 14 parts per thousand, they lived an average of about 80 hours. Down from there at 21, they lived about 40 hours, and then only 8 hours at this highest concentration. So as you can see, they're fairly tolerant to some brackish water and can probably cover quite a good distance in 3 to 4 or 5 days. Another thing that we're kind of excited about is the potential utilization of what we would call pike exclusion structures. Now, a master's student did a project on this a couple of years ago, and lots of research has been done on fish leaping abilities, but mostly on salmon and mostly on trying to figure out how to design the right culvert, or what's the minimum we got to design to get these salmon up and over a culvert or whatever. But pike aren't really known for being very good jumpers. They're more just sit and wait ambush predators. You don't generally see them scaling waterfalls and cascades like you can with salmon and trout. So anyway, she essentially tested to see what the limits of pike were for jumping, and they really aren't very high. So that could be a weakness that we could possibly exploit when we're trying to keep pike from moving upstream in a location. Finally, another thing we do is maintain an interactive pike mapper where you can zoom in and see all the confirmed locations that we have for northern pike. That's on our website. So if you're interested in maybe going fishing for pike, this is a good place to start. And it also shows the current status, whether that be the black dots, which is where we've eradicated them, red being confirmed, or places where we're suppressing them. And then finally, I want to highlight a new pike management plan that we have. We just generated, and it's a really, really large and helpful document. It's over like 200 pages. Tons of partners helped to write it. But if you have any questions about pike and South Central, it's likely going to be the answers in here somewhere. And then finally, I just want to finish with one other note about invasive species. Another one in the valley, it's Elodia. It's known to occur in 3 locations in the valley, I believe: Alexander, Sucker, and Big Lake. And here's a picture from Alexander Lake in 2018 with a pilot holding up thick mats of it, and you can see all the ways the eye can see. All that green is Elodia that's going from the bottom to the surface, and this is impossible to boat through, hazardous for planes to land on, makes it difficult for them to navigate. But the scary thing is it spreads very easily with just one small little fragment, whether that can get attached to the float plane rudder or your fishing gear, your ice auger, your boat. All it takes is one little fragment to start a new population. And so it spreads really easily. But DNR is the lead agency on this one, and they're working on treatments. So anyways, that's kind of all I have. So we might kind of shift to questions now, but there is a little QR code if you want to take a direct link to the pike management plan. Just want to highlight a few very important partners we have in all this work. My contact info is there, email, phone. Feel free to reach out, but at this point, this is kind of all I have. So thank you.
Thank you so much, Parker. It's a pretty striking story you're telling, and it was hard when you had the humorous images up to not laugh when you're talking about something so.
Try to make it as light as I can.
Yeah. We do have a lot of questions for you both on Facebook and coming through the Q&A here.
Okay.
The first one is from Brian Emerson, who is asking, what can be done as full-time residents of Trail Lake to help you document pike there? And are there any citizen science projects that can use volunteers?
Can you say that one more time? That kind of cut out on me.
Oh yeah, sorry about that. Brian is asking, what can full-time residents of Trail Lake do to help you document pike? And are there any citizen science projects that folks can take part in?
Yeah, I mean, as far as, residents that live on a lake, obviously you know, the regulations are very liberal for them to fish for them, and so simply removing as many as you can is great. We're you know, always happy to kind of take samples from people and collect more data. So that's always something that somebody could contribute, but you know, it's kind of tough because legally you're kind of bound to what the sport fishing regulations are for catching these things. Right now, as far as citizen science or getting involved, we don't have any with Fish and Game that I can think of off the top of my head. There is kind of a larger group of people kind of housed under what we call the Alaska Invasive Species Partnership. And there is committees, specifically some focused on northern pike, where, you know, almost anyone and everyone is welcome to get involved and contribute. And so that would be an avenue. If someone's looking to get more involved, they could tap into the AKISP is the acronym. And I'm happy to get more information to people if they're interested in that. But if I think of something else as questions go on, I'll let you know. And I think I might be able to pull up the questions here.
Yeah, go for it.
Looks like Brian and Ruth ask, what do we do with the pike that we remove? For the ones that we net, we collect all kinds of data, gut them, take bones to age them. And then generally what we do, at least we kind of started this year, there's a person that wanted to use them for compost, and we pretty much give them to him to use for fertilizer, composting type of purposes. But other than that, if we don't do that, then we just throw them away. Generally the pike, a lot of people ask about getting pike from us to eat. When we're netting them in the summer, they could have been dead for, you know, 8 hours before we're done with them in the heat of the summer. And I would say they're kind of not fit for human consumption. So we hate giving them to people and potentially making them sick. And then with the ones that we retrieve after like a eradication project, a chemical treatment, we dispose of those in the landfill. We don't want to give those to people, obviously. So that's what we do with those. Looks like the next question was, what age pike were tested for salinity? That's a really good question. We got the pike from Nancy Lake, and a majority of the pike, I believe, were age 1 and 2, with the majority being age 1, which is kind of consistent with the ages that we're kind of seeing a move through Cook Inlet. And then, have you considered eliminating pike from Trail Lake, which is flanked by Sucker and Alexander Lake? It's a semi-closed lake with an occasional small outflow to Alexander Creek, currently all pike. I wouldn't say we specifically have considered that one. You know, generally when we go down the road of eradication, we go through a prioritization list and prioritize and rank each project based on kind of a variety of factors, but kind of, you know, bang for the buck. What's the best, you know, bang for our buck with this money. And so Trail Lake, you know, certainly not ruling it out, but it's definitely one of those that's remote and would be on the more expensive end due to its remoteness. I'm not sure if it's documented anadromous or not. You might know better than me. But those ones that are documented for anadromous habitat generally rank higher on our priority. Ones that aren't anadromous generally don't, because we would like to benefit salmon as much as we can. And then if it's kind of a semi-open system, then we also have the threat of them always returning. So that's where we're getting into the territory of how do we keep them from coming back if we invest all this to get rid of them from a location. We have to keep them from coming back. So if that threat's there, we have to address that threat as well. So at some point, it'd be great to get to the ability to treat these remote lakes and keep pike from returning, but we're not quite there yet with our program and research. Let's see. Will, hey, Will, how's it going? Do you think gape limitations has anything to do with pike diets, or is that not a consideration because they have such a large mouth? Yeah, it certainly does. I mean, generally when pike first hatch, they all feed on like, little zooplankton and insects, whatever they can get in their mouth. And as they get big enough, the ones that grow faster, they'll actually like start eating their brothers and sisters, and then just get anything that they can fit in their mouth. So there's certainly obviously gape limitations to a degree. For example, we've seen systems where they're completely taken over by pike, virtually nothing less. But the only other fish that's in that system is like some really big suckers. And the suckers are simply just too big to be eaten by the hammer handle pike in the system. And so, you know, we see that sometimes, but it doesn't take a very big pike to fit a salmon fry or smolt in its mouth. They can be really, really small once to be able to do that. So gape limitations to a degree, but boy, they get big quick and get real aggressive. Stephen asks, what is driving the spread? Just increases in population. Essentially, yeah. The way to think about kind of invasive species spread, it's kind of a curve. And generally when pike or any invasive species get first introduced into an area, the spread can be very slow because the population is low. Then it hits this threshold where there's exponential growth. And that's what we saw in the 80s and 90s, where they just started spreading like crazy. And then it starts to sort of plateau and level out as they occupy almost all available habitat. So we're in that part of it still increasing, but definitely slowing down at this point. So I hope that makes sense. It's kind of a common thing we see with, just invasives in general. When they get, introduced into an area, spread can be very quick and then it slows down. But yeah, their population is definitely kind of increasing. And then, is there any genetic tools on the horizon that could be used to remove pike? Boy, that's a really good question. And I think if we ever did go down that road of being able to really put a hurting on pike in the region, it would be probably some kind of genetic tool. And they're doing some kind of related research to that in the lower 48 with like some other fish, I believe, like brook trout and maybe walleye. But pike is definitely on the list because they are invasive in a lot of lower 48 states as well, particularly through the west. Washington, Oregon, Idaho, those places. So genetic tools are definitely getting looked at, and I hope we get there. That would take someone much smarter than me to figure out. And then Stephen asks, there was a muskie scare a few years ago. Is there any in the state now? Good question. Not that we know of. So for everyone's information, the muskie ended up on the Kenai Peninsula in a water body that was actually real close proximity to a bunch of other pike lakes that we ended up treating. And so it was on the list to treat, but we didn't know it was muskie. That really never crossed our mind. But some crews that were doing some netting there, turned up these funny looking pike, as they call it, and sure enough, they were muskie. And we got rid of that population along with the surrounding pike around that area as well. But yeah, that was a pretty big scare, and we think we know where they came from, genetically traced back to Wisconsin, and only a handful of people on the lake, and it process of elimination, you can kind of get a sense of probably where they came from, but it happened so long ago. It's one of those just kind of difficult enforcement situations. But as far as we know, no more muskie up here. There was also yellow perch back in the day as well on the Kenai Peninsula, and I believe they were treated and removed maybe the early to mid 2000s.
Awesome. There are a couple more questions from Facebook. One is, what is the largest pike that you've seen in the system?
Oh, the largest that we've caught through our netting efforts was probably pike that was 47.5 inches. I forget the weight, but it was on the west side of Cook Inlet there around Beluga. So that was a pretty large pike. And The one at the very end of my presentation was up there as well. That was in the kind of the upper 40s range, had a big fat sucker in its belly. And then the largest ones I've ever seen came from, I believe, Big Lake. There was actually a young girl, I think like maybe 12 or 13 or so, that shot it with a bow and arrow, and it was, or actually is, the world record bow and arrow pike. And you can Google that. So that one was 48 and a half inches, and just a slab, real big. So
That's wild. There's another question on there asking about, would an electric weir barrier with a specific transport around the dam, kind of like they use for sea lamprey, work to prevent pike from coming in via salt water in some systems?
yeah, that's a really good question. So we've done some experimenting with electrofishing with the boats with the electrodes that shock fish that they use all through the lower 48. One, kind of a few things with that. One, the conductivities of our water is generally fairly low, and when you have low conductivities, the electricity to stun fish is not very effective. So you have to have high enough conductivity. In addition to that, a lot of the systems are pretty remote in nature, so you have to have a good power source. And so power is always the big thing, and it's got to be a reliable power source. And it's got to function through the winter. And so it's not really something that's been considered, just due to kind of the logistics of it. And I do know in some places in the lower 48, they use them like to keep the Asian carp from spreading into the Great Lakes. But you're right there, I think, by Chicago, with all the power you could ever need and all the infrastructure and probably favorable conductivity. And they really pump a lot of juice into that water. So it would take a lot to do something up here. And that would be most likely very non-species specific. So you'd block all fish. And at that point, you might as well just build a dam, right? So the idea is to try to just block pike and not everything, because you still want that native fish recovery.
Right. So you brought up a lot of things that are a little depressing. What are you hopeful about in the pike efforts that you have moving forward?
Oh man, it's just can be a depressing environment, is in the sense of you don't get very good news very often. There's not very many wins that we have. Usually it's just kind of losses and taking hits. Ideally it'd be nice to get to the point if we can at least keep it from getting worse. That would make me very happy if we can salvage what we currently have. And I'd be even happier if we can, start gaining some ground. Now, we've made tremendous progress regarding the pike issue in Southcentral, most notably on the Kenai Peninsula. And that was a huge feat in itself, that predated me, but worked with some really great people that were instrumental in getting that done. And so ideally, at least as it comes to the Matsu Valley, kind of chipping away at things where we can and start regaining some salmon habitat and keep it from getting worse would be very good for me.
Yeah, I guess along those lines too. You said that there's 27% of that lake, of those lake systems that don't currently have pike. How are those being protected, and what can they be?
Not necessarily. And well, to answer your question, nothing is being done to protect them from our end. A lot of these are really remote. Some of them are, have the fortune of being in the higher end of drainages, and the gradient to get up there is likely too high for pike, or the velocity of the water is too high for pike to get there. So they might be kind of self-protecting in a sense. But some of them are very vulnerable, particularly through the Cook Inlet, Kinnick Arm, pathway, and we are looking at exploring options for protecting some of those, mainly being like a weir is one option that we came up with, where, you know, we have obviously lots of experience with installing and maintaining weirs, but that would be one tool that we could maybe use. Obviously very labor intensive. Currently the Vogel Lake system on the Kenai Peninsula, because we know the Pike got there through Cook Inlet, we are maintaining a weir to protect that system. And starting next year, we're going to be kind of putting some more effort into that, improving the weir, putting a camera on it, a live box, so that we can, you know, kind of see when we need to go there and, you know, pass salmon over the weir. And certainly if we see a pike, we would be able to stop it and kill it. So that's kind of a tool we have. It's kind of a short-term solution to the pike spread problem, but our best tool at this point.
Okay. I think another question popped up for you in the Zoom question and answer, if you want to grab that.
Okay. Alexander Creek appears to be a lost cause. Why continue to fund eradication? You know, that's a really good question. But again, we're not pursuing eradication there. It's more suppression, just to temporarily reduce the predation that is occurring on juvenile salmon. And I would have to guess, if this suppression has never occurred, most likely maybe the kings would be extinct by now. I don't really know. I mean, they're in pretty dismal shape already, but we have heard reports from people that live around the area, recreate there, about some of the return of the native species, like rainbow trout and grayling, particularly in the upper parts of the drainage. So that's encouraging. But we are looking to be more efficient and effective in Alexander Creek starting next year. We're brainstorming, you know, how we can do that. How can we inflict more mortality on pike to basically exceed the recruitment rate and really drive that population down? But it's kind of hard because there's a lot of other things going on with salmon at the same time, right? They're not doing good across the state. So when you have the pike problem on top of that, it's just a compounding issue that makes it look like it's, you know, a lost cause. But if we ever get to the point of normal production years for Chinook salmon, you know, we would theoretically see that bump back into Alexander, and with the money that we're putting into and efforts into the pike suppression, we would, you know, theoretically see hopefully a good benefit from that. That's where we're hoping to get to. But when you have so many other problems going on, you know, with salmon, it does look very dismal. But we're going to stick with it. We've invested a lot into that system, and I don't think it's time to throw in the towel quite yet. And then another question from Stephen: how often does Cook Inlet have a salinity level that is passable for pike, and how far could they go? Man, that is a great question. And I eliminated that from my presentation because I already rambled, or knew I was going to ramble for so long. But so NOAA actually has this this forecast model where they have modeled salinities and temperatures and all the things all through Cook Inlet. And you have to take it with a grain of salt because it's modeled data, not ground truth data. But I've been able to pick the data from that and really dive into it. And it looks like, if that model data is correct, generally the trend of salinities in Cook Inlet, they're highest right before breakup. So April and May, they are absolute highest everywhere. After breakup, the salinities start to decrease, and they continue to decrease until they bottom out in the fall, like September, October timeframe. At freeze up is when they start to creep up again, because rivers are, you know, reducing in flow, things are freezing up. And then salinities continue to increase until they peak again right before breakup. And so what we're kind of looking at is those periods, particularly of low salinities, you know, where could they move in that time frame, particularly in the summer and the fall. And right now it looks like, you know, they could maybe, I doubt they could move all the way down to like the Kenai River, that far down the peninsula, or down to Nikiski. Likely just probably north of Nikiski would be kind of the threshold of where they could probably get and survive. But the further up that you go, they could probably live for weeks. Like in the Kinnick Arm, they could probably live a really long time. But again, that's kind of based on some model data that NOAA has, and it's not ground truth, but it seems, fairly realistic to me. So great question.
Awesome. Well, we're kind of getting to the end here. If anybody has any more, any final questions for Parker, that'd be a good time. All right. Well, thank you so much,
Cool.
Parker, for covering so much and for spending time sharing, giving such a great presentation to our community. If anybody does have any questions, any additional questions for Parker, he had his email up earlier, or you can reach out to us at susitnarivercoalition.org, and we'll pass along his email. And in addition, I'd like to highlight a few things that the SRC has going on moving forward. Currently, the Susitna Basin Recreation Rivers Plan is up for review. There's a draft plan right now. So there will be 4 public meetings that will be happening over the next few weeks. There will be one in Talkeetna on January 30th from 5 to 7. There will be another in Anchorage on January 31st from 12 to 2. A virtual meeting that same evening from 5:30 to 7, as well as one in Wasilla on the February 1st from 5:15 to 6:45. If you would like any more information on that, please reach out to me at margaret@susitnarivercoalition.org. We will be coming up with talking points for the Rec Rivers draft plan, and the final comment period will end on March 5th. In addition, there is a comment period for D1 lands going on right now. Currently, the BLM has lands that were designated through INCSA that protected about 28 million acres from mining and mineral leases. So there's 28 million acres that have the potential to be opened up, including some lands right around the Susitna Dam site. So we are looking at that, and the final comment period for that will be February 14th, and we'll be getting some information out in our newsletter about how to comment and engage in that. And there are also some other great resources from other organizations on that. On February 20th, we'll be having another winter speaker event. We'll be talking about the history of Susitna Station with Kevin Toothaker, and that should be a really interesting talk about cultural and historical importance of that site. Sioux Station is where the proposed West Susitna Access Road would potentially have a bridge crossing the Sioux. So we're really interested in learning more about the cultural history of that site. Additionally, you can find us on February 3rd at the Willow State Winter Carnival down in Willow, starting at 9 a.m. That's a Saturday, so come learn about some of our work. We'll have some information for you. And with that, thank you so much for being here. This will be available recorded online if you'd like to watch it again. And Parker, do you have anything that you'd like to close with?
No, just thanks for having me. Appreciate everyone's interest and questions. And, as I said, feel free to reach out with any questions about anything related to Pike. Happy to help.
Awesome. Thank you so much for being here. And yeah, have a great evening. Thanks everyone for joining.
Thanks, y'all.